So 8.2c is about graphing the secant. Now, you might recall that a secant is the reciprocal of the cosine. So you'll notice that a few things, hopefully you notice. One, that I have a cosine graph picture. I have a cosine here. Okay, so we're gonna use that to our benefit. Okay, so we have to use the reciprocals. Now you have to be careful when you do this. You have to follow order of operations as we've been doing before. But the reason I wanted to do 8.2c and 8.2d first was because they're so linked to the sine and cosine, and we've started to get that pattern. Let's do these ones first, then we'll go back and do the tangent and the cotangent. So let's put down what we know about the cosine. So we have learned, and from the unit circle and from our graphing, that at 0 we are at 1. At pi over 2 we're back at 0. At pi we're at -1. At 3 pi over 2 we are at 0. And at 2 pi we are at 1. Now remember, our cosine works like this. These two are the upper bumps. These two match. They're the midline. We're on that center line. And then this one is that lower bump, okay? So remember, that's why it goes high, middle, low, middle, high again. So that's what that graph tells us. So let's put that graph on our graph paper that we see here. Let's make this 1 and -1. And we're going to make it a dashed line, okay? So I want to make it a dashed line. Okay, so we have our cosine. So we're just graphing our cosine. It starts at 1, then it goes to 0, make a half a bump. Then -1, back to 0, make a full bottom bump. And then a half a bump at the top. So remember, that's what our cosine parent function looks like. So I'm just going to complete the graph for my cosine. And I made it dashed because that's not what we're graphing. But this one is really awesome as to how it's going to tell us what a secant graph looks like. Okay. Now let's talk about the secant. Now the secant is 1 over the cosine value, or the reciprocal of our cosine value. So the reciprocal of 1 is 1. The reciprocal of 0, because we would get 1 over 0, is undefined. That technically on our graph is a vertical asymptote. The reciprocal of -1, -1 over 1, is -1. The reciprocal of 0, we have learned earlier, is undefined. That is a vertical asymptote on our graph. And the reciprocal of 1 is 1. So let's analyze what happened. Every place that the cosine was 1, the secant is 1 also. Every place that the cosine was -1, the secant is -1 also. But every place that the cosine hits that middle line, we should have a vertical asymptote. So let's go over to our graph paper and let's put that in, okay? So let's put our vertical asymptotes on first. So every place that our cosine hit the middle line or is equal to 0, put on a vertical asymptote. Every place that our cosine hits 0 or the midline, put on a vertical asymptote. Now those are dashed lines. They're very little, but you can hopefully see that. They are dashed lines. Everything right there is dashed. See, everything is dashed. These are not things that are graph. These are just barriers to our graph, helpful information. So everything right there is dashed. I'll leave that kind of zoomed in so you can see that. Okay. So now it's time to actually put our points on. The only points that we have so far is at 1, we are at 1. At -1, we are at -1. At 1, we are at 1. Now that doesn't give us a whole heck of a lot, but let me give you some information. The values we don't see on the unit circle, and this will kind of at least guide you as to where this comes from. Let's talk about pi over 4, 45 degrees. The cosine of 45 degrees is square root of 2 over 2. You might recall that. Square root of 2 over 2 is about 0.707, I believe. And so if you flip that over, you actually get the square root of 2. So the secant of pi over 4 is the square root of 2, which is about the decimal 1.4. So this is going to let me show you just what happens, but you don't have to really show me this part as much. So pi over 4 is exactly between 0 and pi over 2. So that's where the pi over 4 line is, okay? We are at a height of 1.4. Negative pi over 4 is also a positive cosine value. It's at 1.4. You actually get a parabola looking thing right here. Now this right here is 3 pi over 4, 3/4. 3 pi over 4 is in our second quadrant where the cosine is negative. That's about negative 1.4. So that is about, oh, I'm sorry, I didn't make those points very good. I forgot I was counting the way I was. 1.4 would be closer to this. It doesn't matter, but at least for accuracy's sake. And this one would be 1.4 as well. So what you get is you get these little like parabola things. And I think about the fact that the cosine and the secant are reciprocals, and that the secant is bouncing off of our cosine graph. It's flipping somehow the cosine graph. So let's put all of those on here. And if you want to be more accurate, you could be putting on those 1.4s. It's not necessary, but I did want you to see where those come from. So the secant graph, every place we have an upper bump, we have a parabola going up. So the secant graph just has a parabola thing going up, a parabola going down, a parabola-like thing going up, a parabola thing going down. And that repeats endlessly. Now let's look at the patterns. The asymptotes are evenly spaced. Okay. The upper bumps are evenly spaced. The lower bumps are smack down in the middle. They're evenly spaced. Just like our cosine is this perfectly periodic function that is evenly spaced, our secant function will be as well. But you'll notice that the cosine graph will lead me to the secant. So that is our parent. Let's take a look at what we know about our secant function. Go one more. I don't care. Whatever. No, go the other way. I just want to see what you have. Oh, perfect. Okay, so let's talk about what we know. So we're just going to highlight. So if you want to get your highlighter out, remember that A, the front number, tells us the amplitude. Here, remember that it tells you how far away these bumps are from the center. Same thing like a sine or a cosine. Let's highlight this one. If you set it equal to 2 pi, you will still get the period for this graph. Highlight the parentheses here. If you set the entire thing equal to 0, you're still going to get where these upper parabolas, low parabola, upper parabola, low parabola, where they shift left or right. And then because of the, there's still a middle of these going up, going down, going up, going down. The D value on the end there does still tell you where the midline is. Okay, so it is important that you still recall all of those things that we talked about before. All of those things still go together. The A in front tells you how high it is until we get one of these functions, one of these bumps. The BX still tells you how far it is until they wave. The BX minus C still tells you if it's moved left or right. The D value still tells you if we've moved up or down. So you'll notice that the pattern is the same. And that's why I wanted to skip to this page. So let's just practice one more time for example 6, finding each one of these things. So remember, the amplitude is just the absolute value of this front number. The period, you're just going to set that term right here equal to 2 pi. And if there was any coefficient on your x, the period would change. The whole parenthesis, we are going to set equal to 0. That is our phase shift or our start of our graph. So where x plus pi equals 0 or negative pi. That tells me we've gone to the left of pi. Remember the end, it didn't say this, but remember the end is where x plus pi equals 2 pi. Or you can add 2 pi onto your start, and that's going to be your end. If the period is 2 pi, whatever the pi that is. But if we subtract a pi from both sides, 2 pi minus 1 pi is 1 pi. That's our end. Let's see what else I forgot. Period, phase, shift. Oh, last one. Thank you. So the last one here is our vertical shift. So the midline is -3, so we have gone down 3. So you'll notice these things aren't changed. What has changed is the look of our graph. The look of a secant or a cosecant, if you throw it into decimals, you will find these like a parabola going up, parabola going down. Now they never cross over those vertical lines, those vertical asymptotes. They are wedged between them. So unlike our normal parabola, that's why I keep saying parabola-like, a normal parabola keeps widening forever and ever and ever. These parabolas have a barrier. So they'll get really, really closer and closer to that line, but they never really will reach it. So try to make it so that your little parabolas follow those vertical asymptotes. Okay. So remember the characteristics of a secant function. The period is normally 2 pi. The domain, we have to skip every place where the cosine equals 0 or the odd pi over 2s. Yeah.
Can you go back?
Yeah.
I just need the vertical.
Okay. You're welcome. So you're going to skip the pi over 2s, the odd pi over 2s. So like 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. That's every place that the cosine is equal to 0, you're going to have a vertical asymptote. So you can add a little note, VA for vertical asymptote. The range, there's nothing between +1 and -1. However, the amplitude is, you're going to have this gap in the center, kind of where the cosine is living, is the opposite of what our secant, where our secant lives. The symmetry, it is even like the cosine. Now, if you add a phase shift on there, it might not be. And then the amplitude or stretch normally is 1. So that's what the parent function looks like. Now, of course, if we change the function at all, if we manipulate the function at all, these things will change along with it. But we found how to change those things. So let's actually go ahead and graph and find each of the following. So we're going to find the amplitude, the period, the phase shift. We're going to find the start. We're going to find the end. We're going to find the vertical shift and the midline. We're going to do a chart for our cosine value, and then we'll do a chart for our secant, and then we'll do a chart for our nu. So we do have like a little bit more to think about. Okay, so let's go down the list. Okay, so the amplitude, like any other graph, is what's our front coefficient? If we don't see it, it's 1. The period is what happened to our x. We set that equal to 2 pi. I love when this happens, if it's just an x, if it doesn't say 2x, it doesn't say x over 2, anything like that, it's just 2 pi. Our phase shift, we are going to set the parenthesis equal to 0. So we get a negative pi over 2. So that means we've gone to the left of pi over 2. That's our starting place. So our starting place is negative pi over 2. Well, our ending place is always going to be where that equals 2 pi. So just subtract pi over 2 from that. How do we do that? Well, that's a half we're taking away. If we have 2 pizza pies, that's 4 halves. We've taken away a half. So that is 3 halves that remain. So hopefully that might help you a little bit. Okay, so our ending is 3 pi over 2. The vertical shift is just, remember, it's this number right here. If it's positive, we're going up. If it's negative, we're going down. So the midline is at 1. Okay, so let's fill in what we know. So this is 0, 0. Pi over 2 is 1. No, it is not. I'm sorry. I was doing a sign, which is not a good place. Okay, cosine starts at 1 and goes to 0, then negative 1, and then 0. And then at 2 pi, it's at 1 again. So our secant goes 1, undefined, which is a vertical asymptote, negative 1, undefined, which is a vertical asymptote, and then 1 again. So we always know for a secant, we kind of get some bonus stuff for free. Okay, so let's break this apart. Okay, so let's make our graph paper so we can start to kind of see what the heck is happening. And I'm sorry this graph paper is a little bit gross, but I'm going to make the halfway marks the pi over 2's. And I think that should work. So let's make this and I think we should be able to fill in our chart. Well, at least I'm going to try my best. Okay, so look. So this is where we start. 3/2 is 1.5. It's right here. Okay. So let's think about, let's count the jumps to get from here to here. Okay. So 1, 2, 3, 4. That's going to be perfect. Look, isn't there 5 little tick marks? 1, 2, 3, 4, 5. So counting by pi over 2s is all we're going to need to do. So smack dab in the middle was pi over 2. Here's 0. And here is pi. So you can use your graph paper to help you count. Okay. You always have to break it into fourths. So there's halfway mark and there's fourths. Okay. We always know for a secant that the second spot, no matter what, is going to be a vertical asymptote. We always know for a secant, no matter what, that the third spot is going to be a vertical asymptote. So that's a great thing, because we don't have to think about those values. We don't have to do those values. The second spot and the third spot, second spot and the fourth spot. Wait, second, 1, 2, 3. Second spot and the fourth spot for an secant will always be a vertical asymptote. So can we put those on the graph paper? Okay. So at 0, we have a vertical asymptote. At pi, we have a vertical asymptote. Now, they are always equally spaced. So before we do anything else for these, let's put on all our vertical asymptotes. Vertical asymptote. Vertical asymptote. You'll notice they're happening at all of the full pi's. 1 pi, 2 pi, 3 pi, 4 pi. -1 pi, -2 pi, you know. I think you got that. So with these, we get these vertical asymptotes for a secant that always occur in this second and the fourth spots. Okay, so that's done. That's great. Now, this one that is here is going to be an upper bump. Okay, so the secant value is 1. So this is the old secant value plus 1. Well, what's 1 plus 1? 2. So that's going to be a 2. Okay, so that's your old secant value plus 1. Our old secant value plus 1 is 2. So let's go over to negative pi over 2, and let's go 1, 2. Let's make that 2. So we are at a bump of 2. At pi over 2, the old secant value was -1. The old value was -1 plus 1 is 0. So at negative pi over 2, we are at 0. And at 3 pi over 2, our old secant value was 1. These two should always match. So that's going to be 1 plus 1, or 2. So our cosine is here. Like that. Oh, no, I'm sorry. Our cosine is here. So let's do one more thing. Let's put on our middle line is at 1. So that is the smack dab middle value of our ups and downs. Okay, so now we're ready to go. Every place we are up, because the graph doesn't exist in here. That's like a barrier. That's a border. It can't cross. The upper bumps are heading toward the asymptotes there. The lower bump is heading toward the asymptotes there. Upper bump. Now remember, these things are equally spaced, so let's put on, this has to be a lower bump. This has to be a lower bump. This has to be an upper bump. So that is what a secant looks like. In some ways, they go a little bit quicker than a sine or a cosine, but you just have to think about what the cosine value is and then go from there. So that is your first secant graph, it is bouncing off of the cosine, which technically lives right here, and it's bouncing. So every place the cosine has an upper bump, it bounces and goes up, bounces and goes down, bounces and goes up, bounces and goes down. It's a reciprocal. So that's what happens. A fraction becomes something bigger. A big number becomes a fraction. So it kind of flips those values, if that helps you think about that. Okay. Do we have any questions about what you see there for example 7? I believe we graph one more together. And then just like our cosine homework, there's 4 of these. Now these are going to be due at the beginning of next week. I'll check what it says in Google Classroom, but I believe it's either maybe Wednesday of next week. Huh? Oh, there's only 2. Hey, that's even better. Okay, so do we have any questions before we move on to the next one? The look on your faces is priceless, I'm just saying. You're like, why are you torturing me with this? It's my job. You get to torture students, it's great. Okay, so now let's do one more. Okay. So the stretch is just the amplitude. Technically, it's not an amplitude. It doesn't have a wave height, but you can call it a stretch for these as well. Okay, let's put on there a midline. Let's put on there the start and the end. I think that's about everything. Okay, so let's make some charts for our cosine and our secant, just the original. Okay, so this is 0 and 1. Pi over 2 is 0. Pi is at -1. 3 pi over 2 is back to 0. And 2 pi is at 1. So remember your cosine goes. 1's on the 1st and 5th. The 2nd and 4th are always on that midline 0. And that's the down one. Okay. So let's flip those over. So the secant's always going to go 1, vertical asymptote, -1, vertical asymptote, and 1. Now that you just got to keep that in mind as we graph these functions. Okay. So the amplitude and stretch of this graph is 4. There's no flip. If it was negative, an upper bump becomes a negative bump, a lower bump becomes, okay. The period, we're going to set 2x equal to 2 pi. So this one has squished in a little bit. The period is pi. So there'll be an upper bump and a lower bump in a length of pi. Phase shift is where 2x minus pi equals 0. Remember the entire parenthesis. Where does that equal 0? So we got to add a pi. We've got to divide by 2. So that starting place, or our phase shift, is pi over 2. So we get the starting value. We get a starting value of pi over 2. Let's find our ending value. We're going to set 2x minus pi equal to 2 pi. Now we should just add a pi to the starting value, so that's another way to do that. But let's see, that should work out. So 2x equals 3 pi's. Divide by 2, that's 3 pi over 2. That's the same as adding a pi to pi over 2. That's 3 pi over 2. Now, smack dab in the middle of 1 pi and 3 pi's is 2 pi over 2, or pi. In the middle of a half and 1 is 3/4. This is 3 pi over 4. And the smack dab in the middle of 4 halves and 6 halves is 5 pi over 4. So we need fourths showing up on our graph. So let's do this. 1, 2, 3, 4 pi. I think that should get us what we want. 1, 2, yeah, that'll do that. It'll barely do it, but it'll work. And then we need a pretty high stretch. So let's just 1, 2, 3, 4. Oh, okay. I'm jumping slightly ahead of myself, but okay. We're just counting one by ones there. So at least we got our graph paper set up. The vertical stretch is that number right there. So that's 1 up, or y equals 1. Our ending we found was 3 pi over 2. So I think we have everything now we need. Okay. So what's great about the the second spot is a vertical asymptote, and the fourth spot is a vertical asymptote. So let's put on all the asymptotes we got on our graph paper, okay? Okay, so we have a midline at 1. Let's put that on there. So we have a vertical asymptote at 1/2 of a pi, which would be here. Oh, I'm sorry, we do not. We have a vertical asymptote at 3/4. 1, 2, 3. 3/4 is right here. Okay. We have a vertical asymptote at 5/4. So 1, 2, 3/4, 4/4, 5/4 right here. Now, as soon as you find that spacing, we're going to put every vertical asymptote on our graph paper that can fit. So it's every 2 of my blocks. So there's got to be one here. They're equally spaced. There's got to be one here. They're equally spaced. There's got to be one here. And there's got to be one back here. So there, we're good to go. Okay. So get your graph paper all ready by breaking down your X's and Y's, however you want to count is good with me. Put on your middle line and put on your vertical asymptotes before we try to figure out where our bumps are at. Okay. Okay, so hopefully you've got that much. Okay, so let's look. This is going to be 4 times our old value plus 1. Okay, let me say this again. 4 times our old value plus 1. So here's our old values. 4 times 1 is 4. 4 plus 1 is 5. So at pi over 2, we have an upper bump at a height of 5. So this is pi over 2. We're at an upper bump of 5. The upper ones always go up. At pi, we are at 4 times -1. That's -4 plus 1 is -3. We're at a lower bump at pi. We're at a lower bump of -3. Those lower ones always go down. Now, we don't have to even put the final one on the chart, but 3 pi over 2 is an upper bump. Remember, these two always match. These two always match. This one is the only one that's different. So this has to be a 5, so that's an upper bump. So this one has to be a down. This one has to be an up. This one has to be a down. This one has to be an up. And another thing to look for is these should be the same height away from your middle line, because that's kind of like the stretch of the amplitude. This is your gap. Your gap is 4 up above the line, 4 below the line, 4 above, 4 below, 4 above, 4 below. So these patterns have lots of patterns. These are equally spaced. These are equally spaced. These are equally spaced. So there's all those things that are equally spaced. So that is graphing a secant. And if you flip down, you are just going to be working on, for this homework, number 1 is a secant, and number 3 is a secant. Okay, so you're going to be working on 1 and 3. That's what you turn in for the 8 to C portion. So there you go. And let me go back to this so in case if anybody else still needs anything from that graph. So I'll leave it right there.